All right, we're going to do day 2 of implicit differentiation. So we are considering the curve given by that equation, which we can see a graph of there to the right. Part A is asking us to find dy over dx. So just like we did in our lesson yesterday, okay, you may try pausing the video here. Try this one out on your own. See how you do. All right, so hopefully this is what you came up with. 3y squared dy over dx plus 2y dy over dx minus 5 dy over dx minus 2x. No chain rule piece required there because it would just equal 1, and then derivative of constant is 0. All right, I'm going to move the 2x to the other side, and all three of these get a dy over dx factored out. So dy over dx times 3y squared plus 2y minus 5 is equal to 2x. So last step will be to divide and get our dy over dx by itself. 2x over 3y squared plus 2y minus 5. All right, part A is done. Part B, write the equation of the tangent line to the curve at the point 1, negative 3. So if you want to come over to the graph over here, we can kind of look at that point. 1, negative 3 is right there. And my tangent line would look like that. So I'm trying to write an equation of this line. Okay, so I already know my x and y. So the only other thing I need to know is the slope. And we just found something that represents slope in part A, dy over dx. And we can evaluate that at the point 1, negative 3. All right, so that is going to be 2 times 1 on top over 3 times negative 3 squared plus 2 times negative 3 minus 5. So that gives me a 2 on top. Negative 3 squared is 9, times 3 is 27. 2 times negative 3 is minus 6, and then minus 5. So that's 2 over 27 minus 11 is 16. And that reduces to 1 over 8. Okay, so our slope is 1 over 8, and I have my x and y, so I can go to point slope form. Y plus 3 minus a negative is equal to 1/8 times x minus 1. Leave our answer like that. Part C. Find the coordinates of the points on the curve where the line tangent to the curve is vertical. All right, that's interesting. We've seen a lot of horizontal tangents that we have to find. So this one's asking for vertical tangent. So just looking at my graph over here, it looks like there might be a vertical tangent right there. Might be another one over here. This looks like an even function because it's symmetrical over the y-axis. And I think there's probably one right here and one right here as well. So I'm thinking I'm going to find 4 points when I do this. All right, so when we've done horizontal tangents, we've always set our derivative equal to 0 because horizontal lines have a slope of 0. Okay, so think about the slope of a vertical line. You want to set your derivative, dy over dx. I'm not going to put equals because it's not really equals, but the derivative has to be undefined. All right, to get a vertical slope, you have an undefined slope. All right, so what that means is that the denominator of our slope would be equal to 0. That's how you get an undefined. All right, so we're going to take the denominator of our slope, 3y squared plus 2y minus 5, and we're going to set that equal to 0. All right, this is a quadratic equation, so I'm betting we can factor to get our solutions. We're going to have a 3y and a y. I know I have 1 times 5. I think I'll need to go plus 5 right here and minus 1 right there. Negative 3 plus 5, positive 2. All right, so I get 2 y values. Y equals negative 5/3 and y equals 1. All right, we are not done yet because it said find the coordinates of the points on the curve. Okay, so that means that we have to plug these answers back into the original equation. This is the curve right there. Okay, we can't call it the function because this is not a function, does not pass the vertical line test. All right, so that's why it's called the curve. So whenever they refer to the curve, they're referring to this equation right here. So I can plug this in for y, both of them, and then I should be able to solve for x using some algebra. All right. I'm gonna write the equation down here so I don't have to keep scrolling back up. And just make sure. Okay. All right. So I'm gonna start. We'll start with the easy one. We'll plug in 1 first. So I get 1 cubed plus 1 squared minus 5 times 1 minus x squared is equal to -4. So that's 1 plus 1 minus 5 is -3. All right, so I'm going to add x squared over here, but I'm going to write it first. And that means I'm going to add 3 over here. So I get x squared equals 1, square root. And don't forget to do a plus or minus when you square root. So we get x equals plus or minus 1. All right, so that's going to give us 2 solutions. We get x equals +1, comma, y equals +1, and x equals -1, y equals +1. Okay, y is equal to +1 because that is the y value we plugged in to be able to solve it this way. All right, we'll do it one more time. Now we'll do the harder one. Y equals -5/3. So we get -5/3 cubed plus 5/3 squared plus 5 times 5/3, -5/3, negative, minus x squared equal to -4. All right, -5 cubed is -125. 3 cubed is 27. -5 squared is +25. 3 squared is 9. 5 times -5 is -25 over 3. I'm going to go ahead and add the 4 over here, and I'm going to add the x squared over there. All right, I'm going to rearrange my equation by putting the x squared first. X squared equals, and then I need to get a common denominator. Okay, I think 27 is going to work. So -125 over 27, we're going to leave that how it was. Multiply this by 3 over 3. So that would be plus 75 over 27. Multiply this by 9 over 9. Minus, all right, what is that? 180 plus 45, 225 over 27. Multiply this by 27 over 27. So 4 times 27, that's 80 plus 28. So that's 108 over 27. All right, combine those together. X squared is equal to, all right, -125 plus 75, that's -50. Right, that takes those out. -50 minus 225 is -275. All right, I'm hesitating because we should be getting a positive number here. So something isn't going right. All right, I'm going to pause the video for a second, and I'll come back. Okay, I found my mistake. Silly error. All right, so in the original formula, it was y cubed plus y squared minus 5y. And so when I wrote it down over here, I wrote plus 5y. So that is a minus right there. Which makes that a negative times a negative, which is a positive 25 over 3. And then when we multiply by 9 over 9, we get a positive 225. Okay, so I had, get rid of you right there. All right, so I had -50, -125 plus 75 is -50. And then 225 minus 50 is 175. 175 plus 108 is 283 divided by 27. All right, so now we need to square root, and we get x is equal to plus or minus the square root of 283 over 27. Hey, I'm not concerned about us simplifying that any further. That is good enough. I'm actually going to have us plug it in the calculator here in a second to verify that it matches what our graph says. But we can go ahead and write out our answers. Positive 2 square root of 283 over 27, comma, -5/3, and negative square root of 283 over 27, comma, negative 5/3. So negative 5/3 is our y value because that's what we plugged in for y to solve the equation. And then we get the positive and the negative version of that. And there's the 4 points. And we remember we identified that we should have gotten 4 points. So these two are very easy to identify. If we go up here, we have -1, +1. That looks like that point right there. Good. We have +1, +1. That looks like that point right there. Good. So our other 2 points should be here and here. So it looks like 1, 2, 3, and a little bit further. And -1, -2, -3, and so a little bit further than the 3's. All right, so let's plug this in to our calculator and see what we get. All right, so we have square root 283 over 27. I want decimal form. All right, there you go, 3.238. And then if you then you have the negative version as well because the negative square root. And that matches up exactly with what we saw on the graph. Okay, if we look at the y value, we should see negative 5/3, which is a little bit higher than 2 right there. So -1, negative 5/3, right about there. So I think we are good to go with that. All right, so hopefully you enjoyed that video, and I will see you for the next one.